Everybody, we're doing a 4-pin demo. This is using the module which you can get very inexpensively on eBay called the HC-SR04. It consists of ultrasonic sensor with VCC for power, which I've wired to 5 volts, ground GND, which I've used a black wire for ground, and 2 pins. One is called trigger and the other is called echo, which I'm using as green and blue wires respectively. To show distance, I'm using these 3 LEDs, which I've plugged directly into the Arduino mezzanine bus, and you can see that this entire setup can be done without any breadboards at all, although breadboarding is not a bad idea. We kind of don't need it here. And what you do, and this is kind of cool, is you drag this out so you can make a little space, click on the little crystal, and now you've got yourself a nice little range facility. But you want to be able to see the LEDs at the same time. So when you grab this, sort of bring things a little closer, zoom out a bit, and then you can see how this works. And now you can see the LEDs are turning off and the LEDs are turning on. Let's zoom in just a little bit. And you can see that a little bit better. So now you've got a measure of range based on the LED output. Let's take a look and see how the code works on that one. We'll stop the simulation, take a look at the code. It's pretty simple. I used a for loop to set up the pins between 9 and 14, all as outputs, and you can see why that's being done right over in here because that's where all my LEDs are sitting. And I even made use of the little ground over in here. So basically all you have to do is assert pin 13, 11, and 9 to turn on the 3 LEDs. The reading of the ultrasonic sensor requires both a trigger pin and an echo pin, which I've wired up to pins 7 and 6. But we've parameterized that in case you want to add some more echo sensors. We've got to assert the trigger pin as low, wait a couple of microseconds, and then assert it as high, and then wait for 10 microseconds for the return chirp. Do a trigger low, and then take a look at the echo pin, and we get the sound wave travel time. That comes in microseconds, and what you want to do is multiply that by a number that represents something for converting from microseconds into distance. And so then once you get that, you get it in centimeters, and you can print it out if you like. And in fact, what we can do is we can see what the serial monitor has to say. But the interesting thing, of course, is the visual output. And so what we did was we encoded, tediously, the output to the different sort of LEDs. Now what we could have done, which kind of makes it a little bit nicer, is parameterized the number just a little bit. I mean, it doesn't have to be a lot, but you could do something where you have sort of a procedure that allows you to write out to 3 LEDs, giving them the 3 different states. And of course, if you use 0 and 1, this might actually look a little nicer in terms of the code, but I haven't gotten that far into the code yet. And we could sort of see how that might work if you wanted to. Just set up as a void, write LEDs, and then you want to have integer LED 1. Well, let's just use a comma integer b comma integer c. I would have done LED 1, but the L looks kind of like a 1, so I don't like that. And then what we'll do is we'll do the digital write for A, B, and C to LEDs 13, 11, and 9. And we'll just write out the state A, B, and C. And that ought to do it for us. So then, over in here, you just call write LEDs 000. And then do the same thing over in here, only it's going to be 100. And then do the same thing over here, only it's going to be 110. And, wrote 2 when I meant to write 1. And then over in here, we'll just write LEDs 1, 1, 1. And now it's very clear what the pattern is going to look like just by inspecting the code. Let's see if that compiles, and certainly enough it does. And now let's zoom out a little bit and take a look at these LEDs and see what happens. And sure enough, works just fine. And the code's a lot more readable. So hope you like my little demo. It shows you a little bit about the coding. Thanks a bunch. Talk to you later. Bye.